Hello everybody, and welcome to the AIA webinar for Sustainable Lab Design. Today for the course structure, we'll go through a panelist introduction. We are going to review emerging sustainability trends in life sciences. We'll have an open panelist discussion to evaluate impact to personal practice, as well as sustainability best practices. We'll have a panelist discussion for that. And then finally, a quick review of available sustainability resources. All sustainability trends discussed in this course originate from the Sustainability Trends Lab Design article. For our panelists today, first, I would like to introduce myself. My name is Grace Prem. I will be your host for this webinar. I'm the product manager at Sterling Ultra Cold. I manage the ULT freezers and accessory product line. I've been with Sterling Ultra Cold for 3 years and began my journey as an intern with the company. I've gained responsibility and experience in the medical device space and have a personal passion for sustainability. I recently oversaw the ACT label certification of our SU780XLE upright freezer and plan to continue labeling the freezers in Sterling Ultra Cold's product line. Next, we have James Connolly. James is a visionary sustainability executive with a track record of growing organizations that have transformed industries in multiple sectors, including manufacturing, real estate, tech, and life science. Over his career, he consulted with and developed sustainability programs for some of the world's largest companies and institutions. An internationally recognized corporate sustainability expert, James has deep knowledge of ESG reporting and strategy. James was selected as a GreenBiz 30 Under 30 Sustainable Business Leader in 2017 and a Net Zero Energy Trailblazer in 2019, and is passionate about rapidly catalyzing a global transition to net zero. So thank you for being here, James. Next, we have Charles Blanchett. Chuck Blanchett is a research operations specialist and capital equipment manager at Boston Children's Hospital, overseeing the critical research repository and managing 600 units of cryostorage, as well as providing support for 230 research laboratories across 5 buildings. Chuck has dedicated his career to supporting nonprofits and is excited to be a part of the Boston Children's Hospital family. He also currently serves as CEO of the Key Foundation, an organization that supports and promotes outdoor leadership and activities for youth. So thank you for being here, Chuck. And finally, we have Lindsay Yazbek. Lindsay is the Green Labs coordinator at the University of Texas at Austin, where she has overseen the Green Labs program for the past 4 years. She has a master's in geology from Kent State University, where she studied metal transport and acid mine drainage impacted streams. The UT Green Labs program is housed under the university's Environmental Health and Safety Department, giving Lindsay a unique safety perspective. Lindsay also has experience as a laboratory safety specialist. So thank you all for participating today, and I really look forward to our discussion. So for our discussion today, we're going to go over the current trends influencing sustainable lab design. These include know your research specimen, hazardous chemical use has reduced, don't get hung up on outlets, hybrid working environments, new policies that ensure capital for change, and measure the right metrics to avoid greenwashing. So for the first trend we're going to review is knowing your specimen. So understanding what needs to be stored for your research impacts your project and influences the inputs for your lab design. Research has been shifting to focus on living tissues, and this might require more clean room space rather than working under a fume hood. These types of samples require cold storage at a specific temperature to maintain viability. When you understand the specimen that you are storing, you can determine if this storage process would require a controlled rate freezer or thaw program. Another question to consider is, would your research require secondary containers for racking systems to stay organized and maximize storage? All of these are inputs that should be kept in mind when designing your lab. So we'll get right into our first discussion. I'm going to ask the panelists, have either of you had specimen changes that have impacted your lab in the past, or have you seen an increased need for cold storage?
I'll go
Lindsay
first.
or Chuck, I feel both of you probably have good background in this.
Yes, so there's always growth in labs in our case, and as we're coming up on the next 5 years, we are currently in the process of building another building, which would be 4 more floors of research, similar to the square footage of one of our 12-floor buildings that we already have. So as our research is growing, we're seeing a constant need for more cold storage, and in this case, with the creation of the new building, learning from not the mistakes but our lessons learned through the cold storage in our other buildings, we can see what's more green, what's more conducive to a larger footprint building, such like sharing freezers, making freezer farms instead of each lab having 3 freezers per room. So that's one of the things that we've seen.
Yeah, I'll note too that we actually have a building currently. It's an older building that we have on campus, and they've been having some issues with being able to have enough power, basically, for their cold storage units because they often, pull so much power. So they're having to create freezer farms and other buildings to kind of help get around that issue, which is, not as convenient for our researchers, right? And it's not as convenient for them to go get their samples if they have to go to a different building. So they're looking at, when we're building new lab spaces, how we can think about that. And yeah, is it better for us to do the freezer farms, which we do have in some of our buildings, but just not some of our older buildings. They're just not set up. Their electricity is not set up to be able to handle that.
So have either of you seen a trend toward negative 70 degrees Celsius, the set point for either freezers in your lab?
We have had a couple of labs chill up to -70, as they say, and there's some benefits, and then there's some worry from other folks. Um, Going through the history, when you look at it, maybe 15 years ago or so, most freezers only went up to -70, or only maybe up to -65. As technology grows, the temperatures get colder. So before they were chilling them at those temperatures, and they had no issues, but it's more of a culture change. So to try to explain this to other people and have them move back down from -80 to -70, some people are a little weary about it, but we're seeing it, and it has a good reduction in energy consumption by 30% or so. So those who do it, it does work well.
That's great. That's good to know it's being implemented.
Yeah, and I would just mention, it's one of the first things that we recommend to any lab. We run a free freezer challenge every year where we have a friendly competition that encourages researchers to not only chill up, but also better manage cold storage. Maintenance is critical. Cleaning out freezers, consolidating can actually make a huge amount of difference as well. I will say it's one where even some of the most advanced sustainability labs, there's still some concern about chilling up to -70. And I think there needs to be more data produced, citable data that shows the stability of particular samples at different temperatures. There are some organizations like AstraZeneca that have actually done policy-wide, organization-wide studies to show that the samples that they're storing are not impacted by that change in temperature. Yet some scientists still choose to keep their freezers at -80 because they think it's safer. Another issue with that is, maybe then if you lost power or there's a malfunction, it would preserve a bit longer. And it is true that it does preserve a bit longer, but we're getting some data that shows it's actually not that dramatic. And even at -70, you have quite a bit of time to notice the fault. And everybody, as a best practice, should be monitoring their freezers at this point. We had a pretty visible example recently where millions of dollars of research was lost because the freezer was unplugged. So, I think it's definitely a growing trend, and we just need more data. We need more research to really help change that culture, and frankly, just more education and engagement of researchers that tend to want to keep things the way that they were in the past.
No, that's really great feedback, and I'm glad that there's being changes implemented, and I'm excited to see more of that data that's going to be produced. So I'll move on to the next slide. Our second topic is that hazardous chemical use has reduced and has created a need for additional shared resources. With less hazardous materials used, this reduces the need for energy-consuming fume hoods. Labs are shifting to share equipment in centralized areas and utilizing digital sign-out tools to simplify scheduling. With this shared space, it's important to establish a system to organize and manage chemical inventories to prevent unnecessary waste and overordering. So I'm going to ask our panelists, have either of you seen a slowing of hazardous chemical use? Has this been changing in your labs? Are fume hoods being reduced, at least usage-wise, within your labs as well?
So
I would say, oh, go ahead.
okay, sorry. I haven't seen so much, and it's probably because I work with a lot of different, types of researchers, right? That have, different chemical needs. So I haven't seen as much as that, shift of using fewer hazardous chemicals because of cell work. But what I have
Okay.
seen is an increase in the desire, at least from the design perspective for shared lab spaces. That's something that I get excited about because we know that shared lab spaces are often more efficient, right? So when we're talking from a sustainability perspective, I will say from an environmental health and safety perspective, having shared spaces can sometimes cause some issues. So I noticed on the last slide, you said, you need to make sure that you're managing your supplies and your chemicals if you're going to have it in more of a shared space. That's something that we see sometimes if researchers are really used to having their own specific set space, and then they go into more of a ballroom suite, that can kind of be a difficult transition for them to make in terms of shared equipment and shared inventory. And then we'll find that sometimes if we see something that's, maybe not great that's happening in the lab and we're trying to figure out whose responsibility that is, it then becomes hard to try to determine that. So I think while we have seen and we know that, these shared spaces allow for more collaboration, we do also just have to be aware of, we need to make sure that we're still assigning responsibility for specific places so that if something does arise, we know who to talk to about that issue in a space.
Yeah, I was just
James,
going
did you
to
have
mention it
thoughts?
from a more broader industry perspective. I think it really depends specifically on the type of research. The way that we do research is always changing. It's always developing. I think it's great that we're starting to see a shift to hazardous chemical reduction, implementing green chemistry principles. The manufacturers are starting to create new ways to do analysis that reduce the environmental burden. Additionally, there's sort of like a big shift happening around miniaturization and automation. I just toured an amazing core lab facility for laboratory testing at Northwell Health. And almost all of the testing is now automated, which just changes the nature of how research is done and how analysis is done. And I think what we're starting to see now in the US, which was actually always popular in Europe too, is the implementation of unvented fume hoods, recirculating fume hoods, where the air is just filtered. So when you have less toxic chemicals in the lab, you perhaps don't need quite as much ventilation. And so it allows you to size down or change the way that you're accomplishing the same outcomes, which are all incredibly beneficial. There's a downside to automation and the application of machine learning and AI to drug development and discovery, which it allows you to do a lot more experimentation than we were ever able to do before. And so that actually generates a lot more waste. So I think in this, what you're identifying here, there's some positive trends, but there's also some other trends that are actually increasing the environmental impact of laboratories over time.
No, that's great. Yeah, that's great feedback and good to learn. I think we'll see, at least with AI and other tools, the real effects as time goes along. But thank you both for your feedback on this topic. So our next topic is don't get hung up on outlets and focus on equipment with flexible power supply requirements. So equipment like ULT freezers should have flexible power supply. This is because ULT freezers require HVAC and ample airflow around the unit to compensate for the heat rejection that comes out of the freezer. Freezers that run at a higher voltage are more energy efficient and will be cheaper to run for your facility. Equipment that will accept both 110 to 220 voltage will help you ensure those savings and simplify your facility's electric needs. Another tip we recommend is having a floor plan ready to assist equipment manufacturers to maximize the space with the right equipment. Details like airflow and door openings are important to consider with your floor plan. So for our panelists, have you seen any shifts in optimizing space and energy efficiency with your lab equipment? Are there any special tips you would like to offer when you were designing your labs? I know, Chuck, I'm sure you've had a lot to do with Boston Children's and designing the lab space as well. So I feel you might have a little more to speak on this topic.
Yes, thank you. When it comes to maximizing space, we've seen a lot of people with such a large institution. We have many old freezers, and as they come to the end of their life, which some of them amazingly go almost 20 years sometimes, but they're either very large and hold very little, or very small and hold even less. So a lot of labs have been getting more energy efficient 5-star rating units that have the same footprint but maximize their capacity. And they've also been purchasing different sized storage boxes to accommodate more within the racks, within the space of the shelves that the freezer accommodates. So we've seen a lot of redesign in that aspect. One of the cool things about this slide is it talks about whether the heat rejected is from the bottom or for the top of the freezer. And this has been interesting too, since we have a kaleidoscope of different units from all different brands in all different years and generations, crammed into a lot of spaces. So we find that sometimes it's not so much best to have them have the heat expelled from the top or the heat coming from the bottom, or if we alternated every other freezer to do different. Mainly making sure that your HVAC is a significant capability to handle all the airflow that your freezers are giving off has been the focal point of what we've been doing. And moving to the new buildings, that's what we're taking into consideration.
Oh, that's great. Good to know. I mean, it's always going to be a factor with that older equipment with the heat rejection for sure.
Yeah, maybe
Lindsay,
something I would mention.
Sorry.
One thing I would mention here is that, with COVID and the vaccine and the need for storage, if you walk into most clinical research environments, they're just jam-packed with freezers in every available space in the hallways, et cetera. And unfortunately, I don't think there's a lot of thought given to how that's going to impact the underlying ventilation system. Laboratories are very finely tuned machines to provide the exact right amount of airflow, and the introduction of a brand new machine to a laboratory environment actually should make you start thinking about where the set points are, how ventilation is working in that space, which often isn't done. So I think it's unfortunate that you are very correct to note that there are a lot more freezers now, and it's growing. And I think we need to be really intentional about where we're placing them and really thoughtful. It's not like your home fridge where you can just pop it in and it's not a big deal. It doesn't impact things. It makes a significant difference for the overall building ventilation system. So it needs to be very thoughtfully considered, and requires a lot of collaboration between the building engineer, facilities, the researchers to really get it right.
No, it's great. That's good to know. Lindsay, did you have anything else to add for UT Austin? Is any of this influenced your procurement or purchasing needs with especially equipment?
Yeah, so I will say we do have a Sterling ULT that our Green Labs program owns now, and when we were looking for a space to house that, which was way more difficult than I thought it was going to be, to just find space for one freezer, but we are very limited on space. It was really, really helpful that we did not have to worry about what outlet we were going to plug it into, because it could do the 120 or 220, I believe. So that was really helpful for us because honestly, outlets are such a commodity, especially our outlets that are connected to our emergency power, are a really big commodity for us. So, I think in terms of design too, really thinking about, having enough outlets is something that our researchers, I think, are often complaining about, right? They always want to be able to have more, and especially from a safety perspective, it's really important for us that they do have, the correct number of outlets and that they're not getting creative, which we'll see, some like daisy chaining of, of cords going all across the lab, and we want to try to prevent that as much as possible.
Yeah, I understand that. At least when I've taken customer tours, space is limited in the lab, so it's a lot of valuable real estate, we say. So it's really important to find the right space, and design your lab in that space. So the next topic we'll go into is hybrid working environments and how it's impacting lab design. The pandemic has forced many labs and research to be conducted remotely and resource sharing programs to be created, which actually Lindsay has noted before in a few slides earlier. People had to become innovative with remote observation equipment, and it's important to consider this equipment when designing a lab if it's needed. There are other useful remote monitoring tools that can be utilized via a web browser for day-to-day observation, and all of this should be kept in mind when you are working with IT and procuring equipment, which again, we've actually already highlighted a lot of this. I believe James and Lindsay have commented, but is there been a shift from lab staff on campus daily, Lindsay, at UT Austin that you've seen?
Well, I mean, during the pandemic, there was obviously a very, very big shift. We moved to just obviously only very essential personnel, researchers coming in. So that was, I think, a cultural change, right, for a lot of our researchers to kind of realize that they can do research off campus. But some of our researchers honestly just cannot, they have to be physically in the lab. So I would say that most of our researchers have come back, but I have found now that a lot of them you will be working remotely some days, which I honestly think is really great, especially in a city that has so much traffic, and it's a pretty expensive city to live in. So a lot of our researchers aren't able to live close to campus and they have to commute from pretty far. So we do try to, encourage and support, and I think our administration as well tries to encourage and support that remote work when possible. But yeah, unfortunately for some of our researchers, right, it just isn't feasible.
Understood. James or Chuck, do you have anything else to add for the hybrid research model, how it's influenced you, positive or negative feedback?
One of the things negatively that we witnessed is with everybody working remotely and then the sudden shift back, we had many pieces of equipment begin to fail. And especially in the freezer realm, you figure it would be very similar to see if labs that had samples that they were not using as much, sharing a unit, and then the unit just sitting there for a while. And then all of a sudden the doors are opening and it's being used more. And then that same scenario happened throughout all the other freezers. So we had many preventive maintenance issues that we had to address. And that was probably one of the negative ones. But through that, we've also started test piloting remote freezer monitoring. Now we established our own central alarm system for all our units. But now with the remote units, the reaction time is quicker, and we've seen a decrease in ULTs failing as a result, because people are now keeping up on keeping the ice clean or checking their doors, and the regular part of the freezer maintenance that they should be doing has been brought to light clear with remote monitoring.
Yeah, I would mention that the lab is always changing, the work environment's always changing, but there's always going to be a need for people to actually be in the lab. What might be quite transformative long term is when we're able to do we're able to model experiments. There's the frame used, or the term used in recent laboratory conferences I've been to about in silico experimentation. So actually, instead of doing experimentation on live cells, actually doing it through computer modeling. So, I think there will always be a place for people to need to come into the lab and do experimentation. And that's always going to be important. If you look at the growth of lab space around the world, we're at a continuous shortage of available laboratory space. So the industry's growing, the need for people to be in the lab is growing. And there's some pretty interesting long-term changes that might happen through the integration of IoT and data collection and analysis that I think maybe won't necessarily right away change the lives of researchers, but it'll actually really benefit people like Chuck that are looking across a big portfolio of units and able to manage those assets effectively, do preventative maintenance, understand if they're just operating at a higher energy consumption level than they should be, which is a signal that there's something wrong with the compressor. So I think there's a lot of potential that's going to really improve research fundamentally, because you'll be able to know and have the data chain all the way back down to know that the sample was stored at a consistent temperature over a period of time. So I think it's quite exciting, actually, the new trends that are happening here. But it's not going to reduce the amount of people that need to work in a lab right now, because labs are growing everywhere around the world. And I think that's going to be a continuing trend for quite a while.
Yeah, I agree that labs are going to continue to grow, and it was good that Chuck highlighted the preventative maintenance of freezers and, the good and bad of the hybrid research model. It's obviously impacted everyone differently, and it's good to hear, your feedback from all of you from different opinions on how this has affected you. So the other trend that is occurring is new policies to ensure capital change. The Inflation Reduction Act is an example of one of these policies that has secured $500 billion in climate funding. Researchers and labs should take advantage of policies for energy rebates within their state or on a local level. Many states offer special rebate programs on ULT freezer purchases. These states include California, Colorado, Massachusetts, Ohio, Pennsylvania, Texas, and Washington. And other things to consider are tax breaks and rebates on sustainable material you purchase for your lab. So for our panelist discussion, we're going to focus on, have any of you really participated in these freezer rebate programs? Has it influenced your purchasing in any way, as well as have you seen any tax incentives in a hospital level or university level?
We have seen it's almost a selling point. Sometimes I feel like a salesperson and I'm not, but selling a good quality program, I guess, is where it's at. So when these labs have freezers that are going down, and they're asking my opinion on not such what unit to buy or how much space, or we're looking at all the elements of the equation. One of the key selling points is the $2,000 credit that we get per unit in Massachusetts. So that it helps them make a decision to lean more towards a sustainable unit, which might be a little bit more money, because they do get that credit, and it kind of bounces off because everybody's got a respectable budget, and we try to keep within that.
I have to be frank that I think that unfortunately the Inflation Reduction Act has kind of not specifically thought about laboratories in the way that it's being implemented. So incentives tend to be regional, and energy prices in the U.S. are so regionally based. I live in Seattle. We pay less than 6 cents per kilowatt hour. It can be 3-4 times that in other places in the country. And so the incentives from utilities are really driven by sort of regional factors rather than overall federal push. A lot of the federal rebates are going to residential improvement projects like heat pumps and residential solar, which are all great things and fantastic. Literally everybody should be upgrading their heating and cooling system to a heat pump with the efficiency that they can drive now. But I wish there was more specifically going to laboratories, which make up around 5% of all of the buildings in the U.S. And are incredibly energy consuming. So if there's anybody working at the EPA or with the implementation of the Inflation Reduction Act, we'd love to see more of that money flowing into this space than is. One really positive thing that's happening right now, Grace, is that the US EPA is actually revising and updating the Energy Star program for freezers. There's been massive improvements in efficiency of freezers. So what used to be qualified as an Energy Star freezer is no longer necessarily best in class. I know Sterling has done incredible work and have some of the most efficient units on the market. So I think that will be really good. And then the utility-based incentives that Chuck was mentioning will be tied to this new standard, which is going to drive a higher bar. So I think that's going to be really important. But it's, for me, something that there should be more federal government support for. And I think there's a lot of older freezers that are massively energy consuming, that have refrigerants with high global warming potential, that are potentially leaking. I wish there were the federal program basically to replace all older freezers with newer models, because they're so much more efficient, so much more reliable.
Yeah, I'm really glad you highlighted that, James, with the Energy Star. We're excited at Sterling to hear that it's being improved, because me personally, I do think that there are a lot of freezers. It's becoming a bit saturated with the Energy Star certification. So it's really nice that we're going to be able to, specify units that truly do excel. And it'll be able to teach the customers, what to buy, at least with the freezers. So it's a great thing. And I was aware of that. I'm very excited to hear, when that's ready to go. Lindsay, finally, did you have any additional comments for the slide, or have you seen anything with UT Austin? Have they been investing in any of these programs, or is it used for when you're procuring equipment?
Yeah, so it is a little bit complicated, I think, like James was mentioning, at a university, just because first of all, our energy is produced on campus, which is, unique, right? We have our own power plant, and we actually produce energy pretty efficiently, and it's pretty low, it's not super high price. So there's not as much of an incentive, especially for our researchers, right? They're not receiving the bill for the amount of energy that they're using. So sometimes trying to connect, with them, there's still the need for reducing their energy use can be a little bit difficult. So we're working on different ways, that we can maybe have more internal incentives. And honestly, at the university, they're not typically a fan of the word rebate because I think of the complications that it brings. So we're trying to think of, other kind of similar ideas, right, to reward our researchers for choosing more energy efficient equipment financially, and just not maybe calling it a rebate.
Okay, that's
Maybe,
interesting to know, the hesitation about it.
yeah, and I was going to maybe build on that. Fundamentally, there's something wrong with the way that scientific research is funded in this country, where there's no real incentive for an institution or a researcher to improve the efficiency of their operations. And in fact, if you get to the end of the grant and you have unused funds, you might just buy a bunch of equipment just so you can spend the funds, not necessarily because it's valuable to you. So, we're working on a program. We have a campaign called the Million Advocates for Sustainable Science. You can Google it and sign up for our online petition to get the scientific funders, the funders of scientific research, to be much more intentional about what they require of their grantees. Ultimately, it actually unlocks more research funds, because if you can more efficiently run your labs, then there's more funding available. It's a very slow process in the US. There's some really exciting movement in Europe for some of the larger, both private and public scientific funders to encourage sustainability. And we're hopeful that that trend will continue and progress moving forward. But ultimately, the largest scientific funder in the world is the NIH. That's probably the majority of the institution, that Lindsay's organization received funds from. And so they're the 900-pound gorilla, and we really need to get them to start thinking about efficiency, encouraging efficiency in their grant-making policies. And that's how we'll get the real broad-based systemic change to fully shift the industry into a more sustainable model.
Yeah, thank you, James, for that, additional feedback. And I think it's great that there's a program like that that's been implemented and is being implemented. It's exciting to hear, and I hope, to see the good results, at least from that. But thank you all for your feedback on this discussion. We'll move right into our next topic, which is measuring the right metrics to avoid greenwashing. This is an important trend to at least pay attention to, especially in all of your different spaces. And for our listeners and viewers, just to define greenwashing, it's a term that's used to describe companies that purport to be environmentally conscious for marketing purposes, but are actually not making any notable sustainability efforts. ASG metrics are being developed to represent an organization's corporate financial interests by focusing mainly on sustainable and ethical impacts. So for this trend, being able to have an organization that truly values sustainable efforts is what will really help drive change. Educating the lab and facility management about simple changes to daily practices can have a huge impact. For example, programs like ACT, Energy Star, and Sustainable Supplier Index are great tools for procurement. An effort that would show how small changes pay off is calculating and reporting the organization's total energy use and carbon footprint within your spaces. And we'll dive right into our next discussion. So how are all of you motivating colleagues to participate in programs like this? I know, Chuck, we spoke earlier about how you possibly, participated in a freezer challenge. You have a lot of efforts, at least within your hospital, that you're working on.
Yes. So it started off our first year of participating in the freezer challenge was last year. The Green Labs put together some initiative and started spreading the word and tried to explain it to some labs. And we had 5 labs participate last year. And just with those few labs and the few freezers that took part, we won top clinical for Boston Children's Hospital, which is great. But then when you think of how many labs we have and how many units we have, and it was just 5 labs participating, this year we definitely centered on more of spreading the word or using relatable info and data to share with other labs, putting it into perspective. So if last year we did the freezer challenge and those freezers saved maybe 373 kilowatt hours a day. That's equal to maybe 16 or 19 houses of energy per day. So putting it in terms of houses, it opened more people up to, okay, so if that's what it takes for one freezer, that's insane. What can we do to help? Or if part of their yearly preventive maintenance is to defrost the freezers nevertheless, you working that into a friendly competition, which the freezer challenge is, everybody likes to win at something. We saw a little bit more participation, and then this year we had 28 labs participate, so it was a huge jump, and we saved, I think, 700 and we'll say 60 kilowatt hours a day, which is 35 to or maybe 45 houses a day worth of energy. When we look at the cost analysis and how much a kilowatt is per day, in the sense, I think this year we saved about $56,000. And the year before, maybe $37,000. So putting a money aspect to it helped. And then even the damage that can come to their freezers from letting it ice up, by putting a numerical value on, if your latch breaks because you're jamming your freezer shut, that's a $1,300 part. And then they said, all right, I'm gonna defrost my freezer. And then I say, well, here's the freezer challenge. And so it was amazing how we could work it into the culture or to healthy habits to help kind of spread the word. So even if they didn't participate, everybody in the hospital was working on that sustainability aspect of defrosting their freezers and playing a part.
No, it's really great to hear. I mean, it's awesome to hear those types of results, and it's clearly resonating with the staff. Implementing those types of changes as a part of your daily routine. Like you said, defrosting the freezer is a huge benefit, helps it last longer. Like you said, less handle damage, as well as really putting numbers and data to these types of challenges, I think help push the narrative of how important they are. It's sad when you have to really push money on these types of things, but at the same time, it shows, when, we're pushing these types of new habits and trends, money and the data, it's gonna, pan out to be really positive. So that's a really great example of how this has benefited your team, and I'm really glad to hear it. James or Lindsay, do you have anything else to add on this topic? Are there any specific efforts, you're promoting within your organizations?
Yeah, I think maybe to kind of build on that, the Freezer Challenge is a fantastic program because it gets you quantifiable results. They're estimated results, and we're working to improve the underlying data that we use to make those estimates. But yeah, just putting in front of somebody, hey, you could have saved X amount of energy, and that's equivalent to 4 or 5 or hundreds of houses. Last year we saved over 20 million kilowatt hours from the International Laboratory Freezer Challenge, which is pretty amazing for a pre-program, that really just has one staff person at My Green Lab dedicated to it. And the amount of impact that she's able to have is amazing. I think kind of building upon that, it's an unfortunate reality that we're in a situation of sustainability where people are really excited to claim that they're going to be net zero by 2045 or 2030. And it's sort of like acceptable that claim, validates that they're really on the right trajectory. We have a lot more claiming and carbon accounting and software tools than we do people actually taking action on the ground to implement changes and how they're functioning as a business. So I think we've really got to move from commitment to action quickly. And that's really what My Green Lab certification programs provide, is how to take a higher level sustainability goal or strategy and incorporate it into the daily practice of people at the lab bench, as well as in the lab supply chain. The last thing I would mention is, there's a lot of companies that had lease that they put on things or company created sustainability certifications. We did a research study with Agilent, an independent study, and rightly so, consumers don't really trust companies' own claims. We need to move to a situation where there's third-party verification of companies' environmental claims, and it's going to happen very quickly. The EU just passed legislation that will make all environmental claims be required to be third-party audited. They're going to put new requirements on standards, that they're highly credible, that they're transparent, that there's an open process for change, and they're improving all the time. So I think greenwashing is it's not necessarily a terrible thing, because I think if you commit to something, even if you maybe weren't serious and didn't realize and made it public, your stakeholders are actually going to hold you to account. But I think greenwashing is going to become less and less prevalent because of the requirements that regulatory bodies will be placing, as well as consumer sentiment around what qualifies as a valid sustainability claim.
Yeah, I'll add to that. So I think our researchers are aware of greenwashing, right? And it's kind of been my mission to help them, if they're really excited about a new product that's claiming to be more sustainable, or a recycling program that's claiming, that whatever their product is being properly recycled. I've kind of taken it on to, to be my job to really look into those claims and to start asking the tough questions. And I'll say I've been disappointed in some, organizations that they're not able to answer those hard questions for me, right? They kind of start to, get a little bit nervous when I start to ask those questions. So I do think, it's something that our Green Labs program at UT, it's actually been around for about 10 years or so, in different, stages. It was pretty small for a while and really focused on recycling for a really long time. And I think since we've had more support for our program, and since I've been able to work on it full time, I have really tried to expand what we're able to offer our researchers, which is why I'm interested in things like participating in the Freezer Challenge, which we'll be doing in 2024, or encouraging our researchers to utilize the ACT label, because I know I can point to that those things are really making a difference. Whereas, working with some other groups that are just making these claims that I'm not able to verify, even when I ask them, further questions. So I think it's something, again, to just know that researchers are aware, right? They're savvy. A lot of them, at least, are very savvy to this, and I think it's getting a little bit harder for companies to be to greenwash and kind of get away with it, which is great.
Yeah, that really is great. It's good to know that there's a lot of checks and balances in place for, those organizations that might be greenwashing. And it's good to know that everyone's aware of it. It seems like in every sector. So that's great. So actually, Lindsay did a good segue into our next topic. So my Green Lab actually did a new resource for, which is called the ACT label. It's an environmental impact label that emphasizes accountability, consistency, and transparency around manufacturing, energy and water use, packaging, and end of life. This ACT label makes it easy to choose more sustainable products. So that's personally why I like it. It looks like a nutrition label, something that's easy to accept day to day, what you see on your foods in the grocery store. So it really breaks down, the full life cycle of a product that you're purchasing, whether it's chemical, consumables. They have an ACT label database that I think is a really great resource for people that are procuring certain products for their lab. This is, again, just a really great tool that I'm happy my Green Lab has implemented to highlight, truly sustainable products and how they impact our environment. And finally, there's another program that I think a lot of different sectors could pay attention to is more of your waste resources. So at least when you're designing your lab and what to purchase, there's a lot of take back programs for equipment and packaging that can be used. So a few companies we wanted to highlight were Kimberly-Clark. They are for use PPE like gloves, lab suits, and eyewear. They take those back. Agilent for lab instruments, Corning for all other packaging, and Millipore Sigma or New England Biolabs for styrofoam coolers for transporting certain goods within your lab. This, again, is just a really great tool that I think a lot of labs could be using, as well as other organizations. And for our final panel discussion, we're going to focus on sustainability best practices. So I will ask all of you, are there any improvements that you believe are most actionable in the short term when it comes to sustainability best practices? I feel like we've covered a lot of different topics today that really highlight this as well.
I feel like right off the bat for the most actionable and the quickest would be the separation of church and state, or rather like the separation of trash and recycling and plastic and bio waste, or knowing the difference between the plastics that do go into the recycling. We found through different scenarios here at the hospital where our recycling was rejecting things that we put into the recycling bin because it wasn't coded correctly, or how our recycling essentially is newspaper, cardboard, and bleach bottles. And then other things like pipette tip boxes would be in a different category. And there are other different organizations that pick up our pipette boxes, which we are started to use and test pilot to try to move those forward. So really concentrating on the small immediate things that we know about bio waste, making sure that in those bio bins is not trash. We've done a full effort on pretty much going back to basics, which has helped a lot. And that's our immediate actionable item that we have so far.
Lindsay, did you have any other most actionable items in the short term? I think you highlighted a lot that's already going on at UT Austin, but anything else to add?
Well, like I said, I think a lot of our researchers, and like Chuck was mentioning, they're more familiar with recycling, right? That's something that they maybe do it at their home or that they do other places on campus. So we always try to use recycling as like a first step for our researchers, and then get them to do, what we think are maybe the more impactful things, like participating in the freezer challenge. But really, whatever we can use to help it, get us talking to our researchers and get them excited about sustainability, we're always also excited about. but I talked to someone recently who was starting a green labs program at their university, and they asked me, if you were able to do it all over again, what would you do? And I think one of those things is to really focus more on reuse, right, of materials as well. We have a chemical redistribution program that we've started that, we take a product that researchers don't need anymore for whatever reason, if they're switching experiments that they're doing, right? And instead of disposing of that as hazardous waste, we're now collecting that and then redistributing to other researchers on campus. So I think for us, if we would have focused on reuse more, that would have been really helpful for us. And then also energy, with fume hoods and freezers, I think are some of the big things that we kind of missed originally that we're trying to go back to now and focus on.
Piggybacking off of that too, we have also gone through, reuse is so important. We've gone through many stretches where equipment has been failing or people don't use equipment anymore. So we put together kind of like between the 5 buildings, almost like a Facebook marketplace, community yard sale, if you will. So we do have a list as well as a chemical list too that we've been pushing hard. So when people have incubators they don't need anymore, or small tabletop centrifuges, or tables, so we're able to put those up, and other labs will use those before purchasing other ones. So that's pretty good. We're proud of that as well.
Yeah, that's a really great innovative practice. I think a lot of other institutions could implement something like that, Chuck. James, did you have anything else to add?
Yeah, I love it. I mean, it just kind of goes back to what we all learned in grade school, or at least my generation: reduce, reuse, and then recycle. I think it's really important to look upstream when you're setting up processes and you're understanding how things work. But ultimately, also the biohazardous waste stream that comes out of research laboratories and in huge volume comes out of clinical laboratories is really problematic. Right now, really the only way to deal with it is to autoclave it, transport it to an incineration facility where you're taking incredibly high value virgin plastics and you're burning them ultimately and releasing the carbon into the atmosphere, or you're burying them. And that's not the best and highest use for this waste. So there's some really innovative companies that are pushing the envelope on how to treat and manage biohazardous waste. And there's a study in 2015 that said that plastic waste from research laboratories, academic research laboratories alone, amounts to 2% of global plastic waste. If you add in all the other sources, maybe closer to 10%. So as a society, this is a really crucial issue that we need to solve. And there's some really, really interesting, innovative research that's happening about how we can close the loop, even in biohazardous waste. I would encourage you all to check out My Green Lab and come to our conference. We have an annual conference where we have a number of innovative companies like Envitech, Triumvirate, that are creating brand new ways to think about how to close the plastic waste stream, even in biohazardous. So that's definitely a space to watch.
Yeah, thank you for highlighting that, James. Those are great things to participate in, and all of you had really great feedback for this type of discussion. But that actually concludes our webinar. Thank you to all of our amazing panelists for participating today. I think there's a lot of, great feedback everyone was able to provide, and a lot of great takeaways for our audience and listeners from this webinar. So again, I thank you very much for listening today, and to all of our panelists.